Today we're going to prove that the greatest common divisor of a squared and b squared equals the greatest common divisor of a and b raised to the power of 2. So we will use this theorem, which is called, I will call it theorem star. Which is the greatest common divisor of a and b can be written as ax plus by, where x and y are integers. Okay, or for some x and y, for some integers x and y. Then you can have the greatest common divisor of a and b equal ax plus by. Now let's prove this. So to prove this, we first let a and b be integers such that a is not 0 or b is not 0. And I will let we let m to be a square and b square. Let m be the greatest common divisor of a square and b square. And we let d to be the greatest common divisor of a and b. And try to show that. We will show that m equal to d square. Okay, m equal to d square. So now let's get started. So we might start to prove to. Okay, let me see. We might start with this greatest common divisor. So since d equal to this greatest common divisor, what do we have? So star, what does it imply? The star implies that there exists integers x and y such that, okay, you may use x and y or u and v, that's up to you, okay? Or might be x1 or x2. In this case, I want to use x and y. So there exists x and y, there exists integers x and y such that d, which is the greatest common divisor of a and b, and it turns out to be ax plus by. Okay, so I want to show that m equal to d square. I will first try to claim that m divide d square. So if I want to start with this, I have to show that m divide d square and d square divide m. Now let's continue. Let's prove this claim, the claim that m divide d square. So I might want to start with ax plus by times ax plus by. Okay, so let's find this one. So you're gonna have d square, right? So for this one right here, what we have is we're gonna have a square x square plus 2 b x y plus b square y equal d square. But the advantage for this approach is that for this term, it doesn't have a square or b square as a factor. So if I want to have a square and b square as a factor for all of these terms, we might multiply. So we might find ax plus by times ax plus by square, and it turns out to be d cube. Okay. Okay, I want to start with this and then expand. So what do we have right here? We gotta have ax plus by times a square x square plus 2ab xy plus b square y square, which is d cubed. Okay, which is d cubed. And then what's next? Okay, what's next? So we distribute all of these terms. So we distribute the term with ax into each term. So what do we have? So we gotta have a cubed x cubed plus 2a square bx square y plus a b square xy square plus a square. Okay, we distribute this by into each term. So we gotta have a square b x square y plus 2ab square xy square plus b cubed y cubed equal d cubed. And then take a look at each term. Each term has a square or b square as a factor. So I gotta group the term with a square be next to each other. So we gotta have a cubed x cubed plus 2a square b x square y plus a square b x square y. Okay, and plus what next? The term with b. So we're gonna have ab square xy square plus 2ab square xy square plus b cubed y cubed equal d cubed. Then factorize a square out of the first term. So we're gonna have a square times a times x cubed plus 2bx square y plus bx square y plus b square axy square plus 2axy square plus bx cubed equal d cubed. Okay, equal d cubed. Now, but on the right side we have d cubed. We want to have d square, right? Okay, so you might want to divide it by d square, but we have to make sure that d divide the left hand side. Okay, but we have this one, d equal to the greatest common divisor of a and b. So this is what we have. Now since d is the greatest common divisor of a and b, what do we have? So d divide a and d divide b. That means that we will have, according to divisibility, we're gonna have q1 or q2, which are integers, such that a equal to q1d and b equal to q2d. Okay, then what do we have? We substitute this a into these terms. Okay, then what do we have here? We gotta have, so now we have, okay, we gotta have a square. A now becomes q1d x cubed plus 2 q2d x square y plus q2d x square y plus, okay, give me a second, this is just x square. Okay, b square, what is a? A is q1d xy square plus 2 q1d xy square. Our b is q2d y square. Okay, and this is d cubed. And divide both sides by d, right? Divide both sides by d, what happened? The term with d will be cancelled, right? So we gotta have a square q1 x cubed plus 2q square x square y plus q square x square y and plus b square q1 x y square plus 2q1 xy square plus, okay, q3 q2, not q3, sorry, this is q2, okay, q2 dy cube, but d disappear right now, and equal to d square. And these are integers, okay, these are integers, right? So now what do we have? So since these are integers and we have m, which is, so where is it? M is a square b square, right? Which is the greatest common divisor of a square and b square. So what happened next? Since m is the greatest common divisor of a square and b square, what happened? M will divide both numbers, right? M divide a square and m divide b square. Then what next? Then according to theorem of property of divisibility, so for all integers, let's say, let's use x1 and y1, okay? For all integers x1, y1, what do we have? Okay, we're gonna have m divide a square x1 plus b divide plus b square y1, okay, y1, right? That's what we have. Now take a look at this. These are integers. That means that we can plug into x1 or and y1 respectively. So since this is an integers, right? Okay, I might want to call it x2, okay, which is an integer, and y2, which is this one, okay, which is an integers, right? These are two integers, and since these x2 and y2 are integers, it can be plugged into x1 or y1, right? Because x1 and y1 are all integers, okay? So that means that what do we have? So we gotta have m divide a square x2 plus b square y2, okay? That means that this term is d, right? So we're gonna have m divide d square, okay? Therefore m now divide d square, okay? So we proved this claim already, m divide d square. Now what next? Let's prove that d square divide m square. Okay, let's take a look at this. So we have the new claim, the claim that is d square divide m, okay? D square divide m. Then what do we have? So we take a look at d equal to the greatest common divisor of a and b, right? That means that d divide a and d divide b, okay? D divide A and D divide D. Then what happens next? Then we gotta have D square divide B square and D square divide A square. Okay, let me switch this position here. Now we have D square divide A square and D square divide D square. This implies that D square divide the greatest common divisor of A square and B square. Okay, and this one right here is M, right? Okay, so what do we have? We gotta have D square divide M. Okay, now we already proved that M divide D square and D square divide M. So what do we have? We are going to have that M equal to D square. That means that, what do we have? What is M exactly? M is the greatest common divisor of A square and B square. And D is the greatest common divisor of A and B. So we gotta have the greatest common divisor of A square and B square equal the greatest common divisor of A and B square. Okay, and that's the proof for, and we have proved that the greatest common divisor of A square and B square equal to the greatest common divisor of A and B square. And that's it for this proof.